Hello everyone. In this lecture we will learn about Hofmann elimination via exhaustive methylation. With its name, Hofmann elimination. The name is coined after its discoverer, German scientist August Wilhelm van Hofmann. Now we come with its definition. Hofmann elimination is considered as an organic reaction in which amine with beta hydrogen is converted to alkene using methyl iodide, silver oxide and water under thermal condition. The reaction involves as follows. Here is amine. Then we see the reagent and the condition. First is methyl iodide, second is silver oxide along with water, then the heating that leads to form alkene. Here the reaction begins with the attack of amine with beta hydrogen on methyl iodide that leads to the formation of quaternary ammonium salt, that is quaternary ammonium iodide. Means here exhaustive methylation is done. After that quaternary ammonium salt is attacked by silver oxide along with water that leads to form alkene under the thermal condition. Now we see the feature of Hofmann elimination. First, it is a type of elimination reaction. Here in this reaction we see the beta elimination. The group which will get eliminated are antiperiplanar to each other. So here we also see the anti-elimination. Now thermal decomposition is also seen. As the reaction proceeds to form the product, the heat is given, which leads to decompose the quaternary ammonium hydroxide to alkene. So quaternary ammonium hydroxide acts as main reactant, which leads to product alkene, and the leaving group is trialkyl amine, that is a tertiary amine. Now we see the main feature of the reaction, that is its regioselectivity, which is just opposite to Jacob's rule, that leads to form a rule that is called Hofmann rule, and this feature is discussed later with explanation. Now we learn about mechanism of reaction. Step 1. Formation of ammonium iodide salt. The reaction begins with the attack of amine to methyl iodide to form quaternary ammonium salt. The reaction is as follows. This is beta hydrogen containing amine that attacks to methyl iodide, which leaves iodide ion that leads to form quaternary ammonium iodide. Then we come to second step of mechanism, that is substitution of iodide ion with hydroxide ion. In this step, quaternary ammonium iodide converted to quaternary ammonium hydroxide via reaction with silver oxide to give silver monoxide ion with liberation of silver iodide, and the reaction of that silver iodide ion with water gives the hydroxide ion which forms quaternary ammonium hydroxide. Now we see the reaction where quaternary ammonium iodide is attack the Ag atom of silver oxide to get AgO minus, that is silver monoxide ion, and silver iodide is get precipitated. After that silver iodide ion is attacked to water to give hydroxide ion, which leads to form quaternary ammonium hydroxide and AgOH get liberated. Now we come to third step of mechanism, that is heat mediated elimination leading to product. In this step, mixture is heated which facilitates the elimination reaction. Hydroxide pick up the beta hydrogen from ammonium ion and it releases tertiary amine along with water to give final product. The reaction is as follows, where this is quaternary ammonium hydroxide, where the hydroxide ion eliminates or deprotonates the beta hydrogen from the alkyl group of quaternary ammonium ion to form water on heating along with tertiary amine to give the product alkene. Now come to radioselectivity elimination occurs in the direction that gives the less substituted double bond. That is Hofmann's rule. That means the less substituted alkene is formed in major amount, which is just opposite to Zatsep's rule, in which highly substituted alkenes are formed. Now let us see the example for its explanation. This is quaternary ammonium hydroxide having butyl group which is attached to the nitrogen atom by C2 atom, and there is 3-methyl group attached to it. When we heat this ammonium oxide, we get but1ene as major product and but2ene as minor product. The but1ene is 95%, but2ene is 5%. So we mean here less substituted alkene is prominent. Why this happens? It is explained with Newman conformer. This is first conformer of quaternary ammonium salt, which leads to form but1ene as major product, and here we see the larger group is in between two H atom, means the steric effect influence is less. As compared to conformer 1, conformer 2 of quaternary ammonium salt, that leads to form but2ene but in minor product. Here we see the larger group is in between H atom and the methyl group, that leads to get the explanation of steric influence that is larger in this group. So the conformer 1 that we see earlier is more stable and leads to form but1ene as major in comparison to conformer 2, which is less stable, having more steric effect influence. Thank you.